Okay, good morning. We're going to go over limits today, note card 1. And verbally, if f of x becomes arbitrarily close to a single number L, and they write as a capital L, as x approaches c from either side. So in this case, when they put a c, this is going to refer to an x value. So some x value. In this case, we have c right here, and we are approaching from either side. Let me do this in red. From the left side and from the right side, and we approach a certain value. The output value that is approached is called big L. The input value that is approached is called C in the notation here. And so here's L demonstrated along the y-axis, and here's C located here along the x-axis. So C, you come up here, so you have this point represents a coordinate pair C, comma L. Okay, right here. All right. So the value of the limit is L. And so that's the graphical representation. And then analytically, we went over this yesterday, is we have a limit as x approaches c of the function equals L IFF. You ever seen IFF before? It means if and only if. If and only if the left-hand limit, or in this case they give the right-hand limit, this little C plus sign, right-hand limit equals left-hand limit. Usually when I write these limits from both sides, I usually put the left side first and then the right side. But is it okay doing the right side first and then the left side next?
Yep.
Yes, it is, because they are equal. There's a symmetry about an equal sign, so they are interchangeable about the sign. Now, so we have graphically, analytically, numerically. And numerically with a table. And so if you look at this table here, and then they represent what the table is. So in this table, okay, what is the C value equal to in this table? We're given this table, what is the C value here from the table?
I'm going to go with -7.
Okay, -7. Where'd you get -7 from?
Because every number is close to -7.
Number 7, and also if you look at this thing right here, right? That tells you this. Okay, what is L equal to? 2.6. Now, one thing you'll see, just like the initial problem we did with that, I think it was 8 cubed minus 8 over x minus 2. Remember the table we filled out? We had a did not exist. So f of -7 may or may not be defined. So if we went ahead and had this does not exist, would the limit still be 2.6? Yes. Okay. So you could actually have a point filled in like this, or a hole, either one. So that's just tying together graphically, analytically, numerically. Okay, now we have these problems. Use the graph of f of x to the right to find the limit as x approaches -3 of this function here. So what would be the limit as x approaches -3 of this function here whose graph is located right here.
-5.
So Aaron says -5. So he would say equals -5. And notationally, we would call this the big L, right? How could you test this equation here to see if this matches? What could you do with that thing?
You can divide it out.
You could divide it out. See if you have see if that happens. You could do that really quickly, but we won't do it today. We're going to go on to 2 here. Use the table to find limit as x approaches 3 of g of x. What do you think the limit is going to be here?
10.
Okay, we're approaching 3 from the right and the left, and so we will say the limit as x approaches 3 from the left side of g of x looks like it's 10, right? So that's the left side limit. The right side limit is limit as x approaches 3 from the right side of g of x is also equal to 10. So does this limit exist here? Yes. That equals 10 because the left side limit and right side limit are equal. Okay, so one thing you can see is that test writers will do little tricks with these things. What they'll do, sometimes they'll make this one positive, and this one will look just fine, except you won't notice that there are negative signs over here. Okay, so test writers will do little tricks to try to get you on these things. So just try to remember these rules, and you're gonna be okay. All right. Let's get to this next one here, this exercise set here. Using the graph of h of x, which statement is not true? And this is a multiple choice problem from, it may be from an actual AP test, I'm not sure. And I think there's only one that is not true. And I find on these things, a lot of times, the way to do it is just to kind of go one by one and figure out. So just take a minute and tell me what you think. What do you think?
I think it's D.
Okay. Anybody else besides Aaron? Do you think D? Hannah, you think D?
Yeah. That's what I was
Cars?
thinking, but I'm not too sure.
You're not too sure? What other candidates besides D can you think of, Kyle? You got any other?
No.
Okay. Let's go over these. So if we look at this first one, limit as x approaches A from the left side. So the left side, that's going to be this value, looks like 1. And the right side here looks like we're also approaching 1. And we're looking for which one is not true, right? So this one actually is true, so that's not a, we can cross that off, right?
Yes.
Limit as x approaches C of h of x equals 5. So here's C, and it looks like we have a continuous function here. And from the left side, it looks like we're approaching 5. From the right side, we're approaching 5. So that looks like that's true. So there we go. So D's looking better now, right? Limit as x approaches b does not exist. Well, yeah, it doesn't exist, which means this is a true statement. So that's not good either, right? So now if there is a correct answer, we know it has to be D. Limit as x approaches c from the right side of h of x equals 2. Well, no, it doesn't. It can't do that because we've already determined that that as x approaches c from the plus side has to be 5, because if this statement is true, that means that this thing right here is not true, so therefore that's a correct answer. Okay? And let's go on here. Here you have a so-called homework assignment, and what I want to do is just go over a few of these problems. We're going to, okay. So we have the limit as x approaches 1 from the left side. What is the limit as x approaches 1 from the left side? I'm thinking -2, is that right? And then the limit as x approaches 1 from the right side?
2.
Is 2. And again, these things might look a little bit off. And the limit as x approaches 1 of f of x does what? Do these things equal each other?
Oh, no.
No, they do not. So is there a limit here? No, there is not. So that limit does not exist, because left side limit does not equal right side limit. And what is f of 1?
1.
Looks like 1. Okay, take a second on working on problem 2. Okay, we have the first one here. Limit as x approaches 2 from the left side is x approaches 2 from the left side. What is that left side limit?
3.
Looks like 3. Yeah, Carson, okay, 3. And then limit as x approaches 2 from the right side. What is the value of that right side limit? That's sitting right there on the x-axis.
0.
0, okay, thank you, Kylie. And so what does that limit equal? Doesn't exist. And what is f of 2?
3.
Looks like 3. One thing I had described to me is, as far as limits go, it's like you can consider that the value under consideration is like a fence. Okay? So you got this fence, and you have two people approaching each other. And if they approach each other and meet across the fence, then there is a limit. But if one person gets here to this left side and gets here, there's not a limit. So just consider this x value here, in this case of 2, like a fence. And do those from one side of the fence, do they meet up with the other side of the fence? Okay, next. Let me see how many total there are here. Yeah, Stu, I'll have you Okay. Now this one, number 3, we have limit as x approaches 3 from the left side is,
1.
looks like 1. And limit as x approaches 3 from the right side is 1. And so the value of the limit is 1. And f of 3 is also 1. So what I want you to do, I think that we just have, for the remaining so-called homework assignment, you have just 4, 5, 6. So go ahead and work out 4, 5, and 6. And that is it. Thank you.